Live and work in the UK for an organisation called NIAB. The letters used to mean something, now they don't. We're an organisation of crop science research and implementation into practice. My background is as a soil scientist. As you will see later, and I think you've already heard, I'm always happiest when I'm in a hole in the ground, and we'll see that later. But the question that I was given to explore with you this morning is this question about storing carbon in soil. We talk about carbon budgets, we talk about making sure that systems are net zero, we use lots of terminology. Of course, agricultural systems are part of the problem in the same way as any human activity is part of the problem of producing greenhouse gases. The use of fertilizers, the use of diesel, all of these things are production of greenhouse gases, and the opportunities to minimize those productions is a really important part of what agriculture will need to do going forward. But agriculture is also part of the potential solution to climate change, and that's because it also acts as this large carbon store. The soils of the world have the potential to act as a large carbon store, and good, well-managed agricultural land has a potential to be actually part of the solution to climate change. And so this balance is also really important to us. So it's important for us to understand practically on a day-to-day basis what it means about what we can do. And that does mean saving diesel, not leaving the tractor running when we've just gone into the farmhouse because the cab will stay warmer if we do that. It means stopping doing those sorts of things. It also means looking also at using our fertilizer nitrogen much more effectively and efficiently. But balancing and enabling our soils to be in their best possible health is also important for reducing tillage intensity, because a good soil works more easily, needs less diesel to make the seed bed that we need. A good soil where plants can root well also allows the plant to use nitrogen more effectively, so we can use a smaller amount and recover that through the system. So of course I'm going to say this because I'm a soil scientist, but soils are the most important thing if we want to get our systems working well. In the UK there is a phrase, an old phrase, that comes to the management of soils. Management is a very linear thing. But in the past we used to use this word husbandry. I don't know how well it translates, but the word husbandry is important because I've tried managing my husband and it really doesn't work. I need a different set of skills, which means I pay attention to the context, to look at the little changes, to work in a very different way that's locally adapted and context aware. Husbandry is about the skill of the farmer coming together with the best possible advice and information, and I see that that's where the very best agronomy helps to support and enable farmers to do the best there in combination with their land. But let's get back to the question. It's really important for us to recognize at the beginning that there is no such thing as soil. There are only soils. It's a plural thing. No piece of land is the same as any other piece of land. Each piece of land is unique. The soil forming factors, anybody who sat through long lectures on soil science will know all about the interaction of geology and time and so on, forming soil. But those factors make a unique combination that combines with management in any location to give us a particular expression of the interaction between the underground and the above ground in any location. And we can define that soil from a map. We can understand the type, the likely soil we're going to find, and that's going to set those inherent limits to our production system. It's going to tell us about the likely depth and the rooting depth. It's going to tell us how stony the soil is. It's going to tell us, perhaps most importantly, if we look at a soil map, what the texture of our soil is. That particle size distribution, the amount of sand, silt and clay, those aren't things that we as land managers can change, but they're things we have to work with. We might want to swap them. I'd rather have your soil, but actually we only have to live and work with the one that we have, and understanding the character of the soil that we're working with is key to developing the most appropriate system. And that's very true these days with the ability to look on YouTube and other things at what farmers are doing on completely different bits of the world in different environments and think, I want to do that. Well, the question is, great for them in their particular place. What can I do that's like that in my soil? When we bring or lift a farming system and bring it straight to us, it often, well, breaks. So actually we need to think about what works in our particular soil character. And in that context, the management then modifies the properties of the soils. So actually we as farmers and as land managers, and this has happened on pieces of land for hundreds of years, those properties have changed, the structure, the way the particles hang out together, the scientific term aggregates or PEDs, but just those lumps and crumbs and blocks. And so importantly, the pore spaces between the way the water can move through the soil, the highways and byways that we create, the structure of the soil are critical for how it functions. Together with that, the amount of organic material that we're adding and mixing and allowing to work in our soil is something that's ours to decide by management, the nutrients we add, and those things have an impact on things like earthworms or those other organisms in the soil and a number of other things too. And it's those changeable properties, those ones that we have in our hands to manage, which are the ones we call soil health. If we are starting, and I'm not really talking about soil health, but I'm sure it's a thing that we've been thinking about on farms, we need to think about the health of our soil in light of its character. I'm never going to be a great marathon runner. My genetics, my character just means that that's not something I have in my skill set. But I can run a bit and I can be healthy because I run. And so actually doing the right amount of exercise for the character or the genetics I have is really important. Matching my management so that I'm healthy means understanding also my character. So the two are important, but not the same. At the heart, perhaps, of good soil health is the organic cycling that happens in the soil. Organic matter, the materials that are added to the soil, whether they're last year's crop residue or the leaf that was falling on the surface of the soil from the forest that was there 4,000 years ago, are captured and cycled in the soil. And actually, if we measure the age of the carbon in soils, we often find a number that's 4,000 or 5,000 years old. Not because all the carbon's that old, but some of it is older, some of it's younger. It's in a constant cycle and interaction. And it matters because, well, it helps to support all those functions of soil health. The chemistry, the physics, and the biology. At its heart, this organic matter cycling is actually just the energy cycling in the soil. The sun's energy captured through photosynthesis, fed into the soil, and cycled by the microbes. So the organic matter, the nutrient source released in that process, is also supplying nutrients for plant growth. It's a naturally balanced cycle that we've then worked with to enhance and enable. But in terms of chemistry, particularly in the sandy soils that we see around us, organic matter is important because it adds to the ability of the soil to hold on to cation nutrients. Not just cation nutrients, but those are the ones we're most interested in. To hold on to calcium to maintain soil pH, to hold on to the potassium that we add, the ammonium that we add in fertilizer, and to enable that to be stabilized and buffered in the soil. It also is helping to structure and enable water holding capacity because of the way it changes and interacts with structure. So it's the small to medium sized pores in soil that are the things that hold on to water well and take us through a dry summer. I know one of those in the UK. I think yours was slightly less dry, but still pretty dry. So having more organic matter in the soil holds and gives us that reservoir of water to take the crops through those dry periods. Scientists don't really like the term organic matter because it, well, is all that organic stuff. So they've felt the need, and I'm one of them, to bring this and talk about a particular part of that mix of materials and measure. And when we measure organic matter, we tend to, and in Estonia I know the lab results come back to you as organic carbon. Organic carbon, organic matter, we're pretty much talking about the same thing. It's just how we measure it. So we capture out of the organic matter, 58% of the material through the measurements we use, and the carbon that's there, that's our organic matter measurement. So if you, for some reason, have one or the other, and you see in books people talking about organic matter rather than organic carbon, the 58% number is the number you need to just make that conversion. It's not an easy conversion, so you can also just about just say there's a difference of 2. So if I have 1% organic carbon, I've got 2% organic matter. So that you yourselves can see in those stories that other people tell how those relate to your data. There are a set of measurements that are possible to be made, and dominantly organic carbon is measured by what we call dry combustion, which is what it sounds like. The soil is burnt under very dry conditions in a stream of oxygen, and so that all the carbon that's produced is produced as CO2, and we measure that CO2. This measurement captures any carbonate, that mineral material that comes from lime or from underlying limestones and other rocks. So that has to be analysed separately and taken away. So we need to correct soils, particularly soils that are naturally high pH, and take that carbonate away. The thing to be really aware of is if I send my samples this week to this laboratory, and even then I send the same sample the next week to another laboratory, I'll get a little bit of a difference in the number. These numbers, because soils are variable, are accurate to about 0.2, 0.3% organic carbon in the field. So actually you can, what looks like quite a big change, actually, I've got 2.1 and now I've got 2.4, I would look at that number and say, no, I'm not sure that's different. That might just be the error in the laboratory measurement. I'd want to see a systematic program of measurements that shows me that change through time. If the next time in 3 years I go back to measure and it's increased again, I know I've got that increase happening. So try and stay with the same labs and methods if you're measuring and trying to understand your carbon. At the end of the day, if we're understanding what's happening with the carbon, that carbon balance in soils, we only have to have a very simple model in your minds. And I'm hoping that by the end of this talk, this model will be now imprinted on your brain and you'll never forget it. It's a very simple balancing model. And if you want to think of it like this sort of seesaw, that's really useful. But you can also think of it like your bank balance. So if you pay money into your bank balance and take money out of your bank balance, what's left in your bank balance is a balance between the two. Yeah, if I pay lots in and take not much out, my bank balance goes up. If more likely happens with me, I pay a little bit in and take a lot out, my bank balance goes down. Really simple. Organic matter in soil, and hence organic carbon, exactly the same. How much I pay in, how much I go out, determines what's left in the balance in the soil. So the soil organic matter, that carbon is dependent on how much I'm paying in and how much is lost through decomposition. That's the main process that takes this carbon out of the soil, and that's that natural cycling, the biological process that we need to be happening. So actually as we add more carbon, we will see more CO2 produced. There's nothing wrong with that, but we'll also see an increased stabilisation. We go in, we get that organic matter forming in the soil. So what are the factors that affect this? Okay, if I want to put more organic material in, I'm going to have more organic material to put in. Simple. So what can I do? Well, I can make the best of the photosynthesis I have available. Your nice long summer days. None of those winter short ones, not a lot of photosynthesis happening then, but those nice long summer days, what I really want is as much photosynthesis to be happening as possible. And what that really means is that I need to have as little bare ground in the system as possible. I need those living roots below ground, which build carbon directly in the soil, and the above ground solar panels of the leaves feeding that system. If I'm growing crops, what I really want to do is bring the residues of those crops back as much as I possibly can. Now we know, I don't know so much for Estonia, but in the UK, there's a real market, and this year particularly, a real demand for straw for livestock bedding. And also increasing looking at using straw for power stations and other uses. But if you must, because economics make it a sensible thing to do, if you must bale your crop residues and take them off the field and not put them back, then find a way to, well, borrow some organic matter back. So the first and most important thing we can do is actually make the best of the photosynthesis that's available on the ground, and recognise, at least, to remember in our minds that anything that leaves the field that was photosynthesis, whether grain or residues, is taking that carbon that's been fixed on that field away to somewhere else. We're selling carbon when we sell anything away from the field. And it's really important to recognise, because these active and fresh new bits of carbon we're adding into the system, the bits of leaves and residues that fall on, are really important to the processes that make soil healthy. It's feeding those organisms in the soil, keeping the system going, that's really important. And so those are the things that, even before we begin to see an increase in the number, because it's difficult to measure the number well, we'll see improvements in physical structuring. We often see improved trafficability, that will be a challenge for the translator, and workability, proper agricultural words, in the way that the soil responds to tillage and grow, and how plants establish and grow. So that benefit probably goes ahead of any measured organic matter increase. Okay, so where else can I get my organic matter from? Well, only you know. Because these will ideally be affordable, which means we haven't transported them a really long way, which means they have to be local. Well, so what organic matter is being produced locally? Well, I don't know. And I don't even know when I give this talk in the UK, because every region and every system handles its organic matter from cities differently. Some places have good access to biosolids, we call, or sewage sludge that have been composted perhaps or not. Some places have good green waste compost, because the gardens of the city put all their green waste in one place and it becomes compost that becomes available. It depends. Some places have access to coffee grounds because there's a factory that just happens to roast coffee near to them. And those of you who've ever, I guess Starbucks here do the same thing. You can shop for your very little packet. Well, the big factories do the same thing to improve and so those are opportunities to bring resources, other people's photosynthesis. That's what it is. Somebody else has done photosynthesis somewhere else, I'll have it on my piece of ground. So I'm bringing other people's photosynthesis into my ground. Now, if we're a government looking at sequestration or carbon storage, this may not be carbon storage. Because if those materials would have gone to somebody else's ground and you've just moved them to yours, that's just shuffling, moving bits of carbon about in the landscape. It's not extra sequestration. But you can benefit as a farmer from improving your organic matter on your piece of ground to the benefit of your system. So it's a really good thing for farmers to think about in the context of the bigger picture. For a agronom is more tricky to understand whether that one does or doesn't count and how we make it work in a model. And we know from lots of data collected over lots of years that the answer is really simple, but there is wobble in it. So I've got a really nice straight line here that says the more carbon I put in, the carbon loading along the bottom, the change in the carbon stock in the soil increases. So it depends where I start, what actual carbon number I measure, but the change in the carbon stock. So the more carbon I put in, the more there'll be in the soil. It's nice, simple. Even I can manage this kind of science. Compost is only about 50% efficient in converting to soil organic matter. So that already broken down material is about 50% efficient. So always 50% of the material will go off into the atmosphere. We were talking yesterday about other numbers, and actually when we put in green materials or farmyard manures and slurries, I'm going to change my rule of thumb and say they're usually slightly less efficient. So 30% is probably more realistic. So we've got to think through, if we want to make a model, and most farmers don't need to make a model because someone else will do it for you, how we take the carbon that the farmer says he's put into the ground and make that into organic matter. But as a farmer, we just need to know this bit. If I put in more organic matter, what happens? My organic matter in the soil tends to go up. Nice and simple. And I will get the benefit from that in terms of my organic materials in soil. Now, what about those other side, that bit about paying out carbon? How can I reduce the amount that's released or increase the amount that's stabilised? Well, one of the things that does that is nothing to do with us really, it's to do with that character of the soil. The more clay I have in the soil, the better the carbon is stabilised. And that's because the clay particles in soil have a really big surface area that's very active. We know that because they also hold on to nutrients very well. And so those clay particles make associations with the edges of the organic matter. They basically wrap them up and stop them being broken down. So clay stabilises the organic material in soil. So actually, if I have a field that's 5% clay and next door to it a field that's 10% clay because of something that's nothing to do with me, just the way the landscape works, the field with 10% clay, even if I do exactly the same things, will have higher levels of organic matter. It can stabilise and hold on to that organic matter better. So I need to know that, because actually that helps me interpret the numbers. Oh, look, I've got 3% there and 2% there, I must be doing something wrong. Well, actually I need to take the fact that the texture is different, there is more clay, into account. Otherwise I might panic or worry or do something silly about my management as a response. So it's really important to take clay content into account in understanding the numbers. But there's nothing we can do about it. Well, there is, but I don't think it's cost effective to start driving clay or sand around the country to change our soil textures. The other thing we do know, and something we can do something about, is that the less disturbed a soil is, so the less air we're regularly putting in, the less we break open those aggregates that the clay and organic matter is there, the less the decomposition will be. And this is why that in general, if we reduce tillage intensity in a system, both the speed, energy, diesel use is the easy way of thinking about it. If I use less diesel to manage my soil, actually I'll also get less decomposition. And that's got to be a good thing, because you've saved money on diesel and also reduced decomposition. So it's a good win for carbon, but also for the back pocket, for the wallet of the farmer. This isn't me saying you should not till at all, because actually some degree of tillage can be really important for weed control. Actually, the worst thing we can do is not till and end up with a no crop. We've seen probably some situations where reducing tillage too far has led to no seedbed and no crop. Well, remember, the really important thing here is to put more carbon in. So the photosynthesis piece is really important. So if I do my management so that my crop doesn't grow very well, I end up in a bad place. So optimum management for the best possible crops is what we're looking for here. But if we can do that with less diesel, that's also a good thing. Now, one of the things, if I really want to start building my organic matter, building my carbon in my soil, I can make it anaerobic. Because actually, if I can't breathe, I can't do much work. And so those organisms in the soil don't break down the organic matter in the soil. Now again, you know this, I don't really need to tell you this, but those wet, peaty hollows that occur across the landscape are there because the organic matter that's in those wet, peaty hollows has not been able to break down because the pores are full of water, the organisms can't breathe, and over thousands of years those soils have become much more organic. The same happens when the pH drops below about 5.5. The organisms get really grumpy with you, and so they don't decompose the organic matter so well. So that sounds a bit funny, doesn't it? But what that does is it builds organic matter. It basically layers it on the top. Yeah. What we have, if we have the active pH around 6.5 or so, we get the action of the organisms to now break down and incorporate the materials better into soil. So although we could argue, and there are some places it is argued, that keeping pH low is good for protecting carbon in soil, actually if we also want to grow things and create new photosynthesis, we're actually better maintaining pHs, like agronomists have always told us, in that 6.5 sort of range. Is there a magic number? I think you probably already know from the way I talk what the answer is likely to be there. No. An awful lot of work was done to bring together an awful lot of data the soil scientists had collected, done in the UK, done in other places too, around about the turn of the millennium, to look to see, well, we can see that soils with lower organic matter actually aren't functioning so well in agricultural systems. Is there a magic number that actually if farmers just kept their soils above this magic number, everything would be okay? No, there isn't. No evidence for a particular critical value. What there is evidence for, and I've said already, is that feeding the soil, not just, well, here's some organic matter, Maybe I'll come back and give you some more in 3 years' time, somewhere else in the rotation. But regular inputs of organic matter, keeping that biology in the soil living and working, is really important. And in that space, and we're talking a lot today about cover crops. Cover crops have a real role here, both in providing that photosynthesis for longer, but also keeping that organisms alive when otherwise the soils would be bare. Is it possible to set thresholds for organic matter? Well, actually, yes. And in the UK, we've started to use traffic light colouring in, red, amber, green. Green, you're pretty much what you should be for your soil texture, so taking that character into account. Amber, you're still a way to go. You've got space in your bucket to fill up your organic matter still some more. So you've got some way to go. The work in Europe, applied for the UK, looks at whether you can actually take the clay number from your soil measured properly and relate that to the carbon, and then understand if that clay is full, if the soil is full. And there are clear differences. Some published work showing you here shows some ratios and some things that we could use if you wanted to start looking at whether it was possible to have those benchmarks for Estonia. So it's possible. It's certainly possible for scientists to take the data that exists and make that framework for use, but it needs to be done at certainly regional, sometimes countrywide, but certainly regional level. But you need to be careful about this organic matter stuff. Because if I change my organic matter, and you can now tell me, but I won't make you do it, how am I going to improve my organic matter? Well, I'm going to grow cover crops and incorporate my residues. Yep, that's what I'm going to do. I'm going to make that management change, which is through time going to increase my organic matter to a new equilibrium, comes to that new balance point. That's great, brilliant. Except if I just stop doing it because the market says now that actually cover crops are too expensive and I've got another great market for my straw, so I stop doing it, does the organic matter that I put there stay there? No. So we go back to a new balance point and a new equilibrium. This is also finite. We can only go to the new equilibrium. The balance point, we can't just keep putting more and more organic matter into the soil. That our soils are at their best possible level for farming. Actually, I think soils that are at the right, they're green, if we think about green, amber and red, for their organic matter, will manage better. Crops will root better, they'll establish better. Actually, we'll be able to use less diesel. All of this is great for farming, and possibly might give us some benefits in those other things too that are complicated and difficult to work out, but we've got experts on the front row, so we'll be all right. Because actually maybe we'll be able to sell some of that carbon too, but actually at the end of the day it's also good for me practically day to day as a farmer to have those higher levels of organic matter managed well. So in general, simple rule, add more organic material, get more organic matter. And recognise that changes in that organic matter as a result of changes in practice could take a long time to detect. For me, it's really important not just to talk about organic carbon and carbon storage, but to think about that in that wider context of soil health, to see the other benefits that organic matter can bring as we think about improving soils in the system. And that's also important for greenhouse gases in terms of reducing tillage intensity, better soils, we can do that more easily, or reducing nitrogen fertiliser use. Well, again, better cycling of nutrients in soil, we've got better chance of reducing that nitrogen input. Notice just some things to think about for carbon trading. It's not just sending a soil sample away for analysis. There's the poor sampling people will have to do some really quite complicated stuff that will involve known volumes of soil, often taken with a ring or a core, so we know the exact bulk density is the science term, because we need a stock, an amount of carbon for a known volume of soil, not just a percentage. So we've got to take that lab number and do some other things too. And we also have a specified depth, and the FAO standard is 30 centimetres. As we'll see in the field, actually carbon can build quite happily below 30 centimetres. In much of the frameworks for carbon trading now, we're only looking at that top 30. So there's usually that distinct layer of soil where cultivation's mixed organic materials and has mixed minerals and organic materials together. We see that line, and I've been and stood in the hole, so I can say this confidently that we'll see it later, where the maximum cultivation depth has been in the past. Below that, subsoils usually have much lower carbon, they don't always, and they decrease because carbon's of course coming in from the top. Photosynthesis feeds from the top. We might have some roots at depth, but still most of the carbon from photosynthesis comes at the top. If the subsoil is pale, we can sometimes see, and we will probably see, some roots and earthworm triangles bringing us down into that subsoil. We need to think very carefully though, not just about this depth thing, but also things like stoniness, because actually if my soil is 50% stone, well, that stone's not holding any carbon at all, so actually I've got less volume of soil so this carbon stock conversion is quite tricky. It's not just as simple as taking a sample of soil and sending it for analysis. And to begin to finish us off, I promise, some real data. So these are carbon stocks collected as part of a program for a company looking at how best to verify models for carbon. They come in groups of 3. So they're not labelled so that you can't tell the farms, but they come in groups of 3. So there are 24 there, and they are 8 fields. 3 points in each field as you go along. So there's clearly some fields with lower carbon and some fields with higher carbon. You've got the blue, which is the top. So most of the carbon is in that top soil, but you can also see in some soils there's quite an amount of carbon below 30 centimetres. So actually there are some soils where actually the carbon stored, and there's that number 22, the carbon stored in the subsoil is bigger than the carbon stored in the topsoil. Not something that the farmer has a lot of control over, but actually probably a useful thing to know in terms of managing those sites. Also really useful and interesting to know is that across fields, and this is UK data, and UK is famous for having quite variable soils over short distances, but you can see differences across, so a field is not the same. So if I take one value for a field, it may or may not give me an actual representative value for the whole field. These are done using yield maps to identify zones, and then these samples are targeted at those zones to get the best possible verification. But it's useful and important to recognise that variation. Some of that difference between my high carbon soils and my low carbon soils is, as you'd expect, clay content. So the soils number 16 onwards have higher clay content than the soils number 15 downwards. But even within the sandy soils 15 downwards, there's quite a big variation there. Management affects carbon storage in soil particularly, but not only in the topsoil. So don't forget the balancing thing. Remember your back pocket, your bank balance. Think about the carbon in the soil just in that way. To increase organic matter, my best approach is to put more organic matter in. But it might be possible to also increase stabilisation, and that interaction with reduced tillage intensity, which also brings other benefits too, is important. It's also important to recognise that actually in any field there might be quite large variation in the carbon stock. Often a farmer knows about variable soils. It's useful to tell someone who's coming to sample about that variation so they can take that into account. And I think yield maps together with that local knowledge really help this work best. So farmers' knowledge coming together with expert knowledge to quantify carbon, I think, is the real strength of any system. For me, carbon content is only part of the story. The more exciting part of the story is how managing soils well can benefit productivity and profitability on farm, and also develop soils that deliver all those other functions around water holding, around biodiversity, that actually society needs us to deliver alongside carbon storage. Thank you very much.
Excellent presentation, I must add. Saalis olijatel äkki pärast seda loengut tekkisid mõned küsimused.
Stun them to silence.
Yeah.
So they're going to annoy me in the hole in the ground later.
I hope so, yes. And it's like I said earlier, it's either of the two cases, whether they understand everything or they understand nothing, right? But maybe a quick question before.
There's one just here.
Yes, yeah, Ermo.
Võib-olla küsiks selle Inglismaa kohta, et kuidas praegu Inglismaa nagu võtta keskel, kas praegu seal siis süsiniku sisaldus nagu tõuseb viljakatel põldudel või haritavatel põldudel ja mida inimesed kasutavad peamiselt siis selle süsiniku tõstmiseks mullast?
Okay, so the question was on the basis of UK, what is the general tendency of carbon stock in the ground on farmed lands, and what might be the practices what the farmers are using to gradually increase it or work towards increasing it.
So the simple thing that most scientists say when they look at agricultural land is to say, oh, that stuff that is cropped is lower than that stuff that's in grass. Wow. And we can do big programs to show that. But we can see just from the balance that would almost certainly be true. If we just think about the balance, a grass field, well, more photosynthesis, more roots, so more organic matter inputs and less disturbance. And if that's true over a long period, well, look, more. What about in arable land, which is I think what your question really is asking me for? The data from the long term, so to the data from 1950s through to the 1980s, showed a decline in organic matter in UK cropping soils. Since the 1980s, it's either been stable or increasing. That's changes in, so the UK legislation about crop residues changed. You can no longer burn crop residues. It was a common practice. I'm sure Simon has set fire to many crop residues in his time. So that meant more organic matter was going back from crop residues, and we saw that change in around 0.5% change in average organic carbon numbers. So we see that change. Farmers that have also become more aware of, I guess, the opportunity to do less tillage, that tends to increase organic matter in the top, not necessarily at 15 or 30 centimetres, but change the way the carbon works, and that's also had benefits for the way things work. So what are farmers doing? All the things I put on one side of my balance, looking for external waste organic matter sources. I know farmers using paper crumble from paper mills. I knew farmers using the coffee grounds, the vegetable wastes, all sorts of things as just opportunities to build their organic matter. But what they're really doing well, the farmers who are doing it, is optimizing their photosynthesis. So they're looking at, can they have opportunities for very short season crops from the end of a winter wheat before the next winter wheat goes into the ground. Don't forget, in the UK we have blackgrass, everybody's least favourite weed. So that means our drilling dates for winter wheat are actually now. So there's quite a long gap in the UK between August and now when you can grow what we would call in England normally a catch crop. Between winter cereals and spring cereals, cover crops are more common. And I think 50% approximately of farmers are probably now using cover crops regularly that go that whole over winter season to keep ground cover in place. There's legislation in the UK that rewards farmers for doing that now. And so farmers are getting added payments for keeping the soil covered, predominantly in the UK to reduce erosion. And to reduce what we would call dirty runoff, the water ending up on the road that's muddy. So that's dominantly what that's for, not for carbon, but it has that added benefit. And for me, it's about systems. People are looking at being more gentle in the way they operate and manage their systems, and that tends to allow people to think differently about that balance. More stabilisation processes, more targeted use of organic matter where it makes a difference. I think the really tricky soils are very sandy ones. So this is not necessarily good news for Estonia. Very sandy soils don't have that ability to hold and stabilise organic matter in the way that my clay loam soils of the middle of England do at 25% to 30% clay. They can stabilise organic matter very well. So actually a small change can stabilise in the soil very well. For a sandy soil, it's a much faster turnover and you have to work harder. You have to be putting more in to get that organic matter to build through time. And I'm guessing for most of you this isn't a surprise, because what I'm talking about is just good farming practice that's part of your husbandry and your rotations and your planning now. I guess the one thing that is coming more in the UK is that opportunity for cropping systems to integrate lays and pastures, grassland inside the arable system. That's a very old way of farming in the UK and in many places, which went out of fashion because we could intensify and so on, is now coming back because it helps to stabilise the system. In the UK that's quite tricky because the livestock have mostly gone west and the cropping ground is mostly in the east. But actually there's a real change, and I think for Simon coming back and visiting, it's one of those things that I think we will see more of happening in the UK, that integration of lays and diverse lays with clovers, deep rooting plants and so on alongside arable. So I can talk for hours, you already know this.